Hi everyone, this video is all about the cutting performance on the DMC2 Mini, in particular with 6061 aluminum and cold rolled steel, two very common materials that are used for many applications. It is going to be a longer video since I want to clearly show all of the cutting performance in detail for anyone wondering if this machine will be suitable for their applications. I'll be using the tools that I provide in the endmill starter set, which I sell alongside the DMC2 Mini. This is a set of various sized carbide square nose end mills and some other specialty shapes. The end mills come in 3-flute carbide HRC 55 for cutting aluminum and 4-flute coated carbide HRC 60 for cutting steels. I'll also test our special mini face mill. The face mill is a 10mm diameter single flute insert tool that comes with 20 inserts for cutting both steel and aluminum. I provide some ball and chamfer end mills in the starter set as well, but I won't be testing them in this video since they are never really run at full load anyways, and you can see them in use in my other videos. My plan is to test all of the square tools at their maximum cutting loads, which I have determined by putting the tool parameters into an online speeds and feeds calculator, this one being from machiningdoctor.com. For the smaller tools, the machine, or rather the spindle, is strong enough to push the tool as hard as it can be pushed before snapping it. But for the larger tools, maybe around 6mm diameter and larger, the tool is now becoming capable of more than the spindle's maximum power output. So to figure out where those spindle limits are, what I'm going to do is set up side milling and slotting tool paths at the correct speeds and feed, but then incrementally increase the step over or step down to see and listen to the machine for signs of the spindle bogging down and struggling as we take a bigger and bigger bite out of the material. When I hear it starting to stall, I'll hit the e-stop button and record what values I stopped at, so I know that's the maximum that we can push that specific tool in that material on the DMC2 Mini. Those values can then be saved and populated in my Fusion 360 tool library, so I can use these tools in the future again at a comfortable, let's say 75% of their maximum cutting parameters, without having to manually input speeds and feeds every time I use each tool. The tool library is something I provide with my tools, so you can simply load that into your copy of Fusion 360 and have all of these pre-tested parameters ready to go, which saves you a huge amount of time and testing. So what I have set up in Fusion 360 is 1" by 1" blocks of aluminum and steel material. For each block, I'll start by profile milling around the side of the material at full depth of cut. And for the 6mm diameter and larger tools, I've sketched a bunch of squares on each block starting with 0.1mm widths, then 0.2mm, 0.3, 0.4, 0.5, and so on. Then I can easily do a trace operation to trace out each square one by one, each time cutting more material out of the block, so we can listen and observe how the machine and spindle handles an increasingly difficult load. Same idea for slotting. I'll cut an increasingly deeper depth of cut at full step over to observe how things sound with deeper step downs. So heading over to the machine now, I'm starting with my 2mm 3-flute carbide end mill in aluminum. In this case, I'm cutting at the maximum parameters the tool can tolerate, and the spindle is hardly under any load at all. In fact, the sound of the motor's fan is louder than the cutting itself. From this point, I'll let things play through and stop to add any useful commentary so you can hear how the machine and spindle sound under various heavier loads with larger end mills. Towards the end here, cutting with a 6mm tool at 1mm step over sounds like about the most you'd want to push the spindle, since it's audibly starting to bog down. I e-stopped the 8mm tool here at 0.4mm step over, since it sounded like it was just beginning to bog down. I also didn't set the part straight in the vise, as you can see the slightly offset cut in the beginning. Now moving on to the steel parts and coated carbide end mills, here is the 2mm 4-flute end mill. I probably should have e-stopped that a little sooner, but it's interesting to see that the machine is not chattering even while it's dumping nearly all of its 2.2 kilowatts of power into the cut. That's very ideal. It means the frame of the machine is stronger than the spindle needs it to be, so we can make full use of the spindle power in pretty much any situation. Now for the facing tool, I've used the Machining Doctor speeds and feeds calculator again to figure out some numbers, and then I am gradually stepping down deeper and deeper at full width of cut to listen to when the spindle is starting to bog down. Keep in mind, this tool is not really for fast material removal, it's more just for clean and shiny top surface finishes. So after all of that cutting, here is what the leftover pieces of metal look like. All of the cut surfaces are left extremely smooth, which is an excellent sign that the machine is maintaining its rigidity under heavy load and not starting to flex, which would cause chatter or ripples to appear on the surface. That's something very prevalent on other small form factor machines, especially ones that try to use wood routers to attempt to cut metal. Anyways, that's all for this video. If you haven't already, check out the DMC2 Mini detailed video to see everything else you need to know about the DMC2 Mini if you are planning to buy one. Thanks for watching, and I'll see you in the next one.